Hello, good morning, students. I welcome you once again to my online show, video shows. Okay, so last video I discussed about the syllabus. I discussed about the contents, the mark distribution, and then the introduction to the computer. So we started with the first chapter, that is evolution of computer. Okay, that is from unit 1. So today we're going to continue uh, from the same chapter. Okay, and like I said yesterday, we'll start with functional components. So if you have your textbook, okay, while you're watching this video, okay, keep the textbook in hand. So uh, if you still don't have the textbook, okay, do not worry. Okay, I'll go through some of the important uh, paragraphs, okay, so that you can understand. Okay, so today we'll be discussing about the functional components. Okay, like I said yesterday, if you see in the textbook, okay, you have a diagram, that is figure 1.2, function units of a computer system. So you have a block diagram, okay, in rectangular blocks. It's what is in the on the leftmost part, it is written input. Okay, within in the middle, within the square block cube, okay, it is written there on top CPU. So the CPU is divided into three parts, that is memory, CU, ALU. So we'll all see them all one by one. Okay, and then if you follow the direction of the arrow, okay, on the right hand side, that is the output. Okay, so input, if you remember the whole concept or the logic behind the computer, okay, input, process, output. Okay, so input, the CPU is does the processing, okay, and then finally you get the output. So like I said, be it your mobile phone, your tablet, okay, your digital watch, okay, if it does the work of the input, process, output, okay, it's same like a computer. Only thing is that it is called by a different name. Okay, so let me just read out on that. Okay, computer is also a type of system because it is a group of integrated parts which is used to solve any general purpose problems by executing the suitable programs. Okay, integrated parts. Okay, different parts, components uh, fitted together to form the computer. Okay, so you have your input devices, you have your CPU inside the cabinet, you have lots of different components. Okay, and then you have your output, you have different types of output devices. Okay, so all of these integrated parts forms your computer. Okay, now the computer has the following components. Okay, memory to store data, to store temporarily data and programs. Okay, then storage devices, that is a mass storage device to permanently store data. Okay, command mass storage devices includes hard disk drive and CD-ROMs. So permanent storage, temporary storage. Okay, and then you have your input devices, that is your keyboard, mouse, etc. Okay, I'm sure that all of you are familiar with the term input devices, output devices, right? Okay, so output devices, you have your monitor, you have your screen, you have your monitor, you have your printer. Okay, the most basic output devices. Okay, and then you have your central processing unit. Okay, which I'll come later on. Okay, and then you have your operating system. So in here, the word the operating system, that is a program that lets you access the computer contents and that runs the program. Okay, so that is in the following chapters. Operating system, a whole chapter is dedicated to that topic. Okay, so operating system is a, in short, I'll just say that operating system is your software through which is run on the computer, through which we users, okay, end users, naive users, are able to make use of the computer. The most basic of your operating system would be you are right now you're using, suppose like in your desktop or laptop, you're using Windows 7, okay, Windows XP, like Windows 10. All these are what is called as operating system. Okay, it's basically a system software. Okay, applications, programs that accomplish a specific purpose that helps you get your work done, such as word processing, calculating formulas. Okay, so application software, system software, application software, you have your MS Office, you have your this thing, Adobe Photoshop. Okay, You all of these things are your what is called as application software. So that is also in the following chapters, that is in the next chapters. Okay, so I'll explain to you on that topics. Okay, so in brief, this is what is comprised of the functional components of your computer. Okay, all of these things makes up your computer. Okay, so first topic is input output unit. Okay, it did not say input output device. Okay, but input output unit. Okay, so to define what is an input or output unit. Okay, now in the note part you will see that those who have a textbook, if you see the note part, okay, computer uses input unit for data entry and instructions fitting purposes. Some of the input devices, so now it says input devices, not unit, okay, are keyboard, mouse, joystick, light pen, barcode reader, MICR, OCR, OMR scanner. Okay, uh, all of these input devices and the output devices is there also in another chapter. Okay, detailed explanation is given about all these devices like MICR, OCR, OMR, like that. Okay, so what is the main purpose of your input unit? Okay, to accept data that is entered from the outside world, that is means from the user. Okay, so what with the help of this input device, what we can do is that user from the real world, okay, can enter data. Okay, real data information can be entered and stored in the computer. So here computer uses input devices for data entry purpose. Okay, yesterday I explained to you about data, right? Collection of raw facts and figures. When you so a collection of raw facts and figures, when you process it, okay, you get the useful information. Okay, so that is done with the help of the CPU. When you press 1 plus 1, right, when you press 1 plus 1, it does nothing, the computer will do nothing. But when you press enter, or when you press equal to, right, it gives you 2, which is an information. Okay, so you get an idea that 1 plus 1 equals to 2, that is an information. So raw figures, okay, added up to give an information. Okay, so some input devices allows direct communication between user and computer directly from the keyboard, right? When you press, as soon as you press it, the information goes and it gets displayed on the monitor, right? So that is a direct communication. Okay, while others require data to be recorded on an input medium such as magnetizable material. You think about your magnetic tape, you think about your CD, DVD, okay, so all of these things has to be recorded, right? Your input data has to be recorded on that. Okay, so that is on a indirect basis. Okay, so input as a term refers to the process of transferring data or program instructions into memory from some uh, peripheral units. Okay, when the term peripheral units, okay, it talks about peripheral devices. Okay, when you say peripheral devices, okay, your mouse is a peripheral devices which is attached to your to the cabinet box. Okay, then the printer is also a peripheral devices. Your keyboard is a peripheral devices. Your monitor is a peripheral devices. Okay, all of those things which is attached to the cabinet, okay, and which accepts the instruction, okay, process from the CPU. Okay, all these things are called as peripheral devices. Okay, I hope now you understood. Okay, so these are the following functions that are performed by an input unit. Okay, so you have 3 points here. It accepts or reads the list of instruction and data from the outside world. Okay, see, it accepts or reads the list of instructions and data from the outside world. Okay, so the only way so whatever real life information, okay, real life data you want to process, okay, you give that data or information through the keyboard, through the mouse, like that. Okay, so that is what an input unit does. Okay, accepting the data, then what it does, it converts this instruction and data in computer acceptable form. Okay, now this is the second point. Okay, it converts these instructions and data in computer acceptable form. Now computer is a machine. Okay, computer is a machine. We have now we from our primary school stage, okay, we learn languages, right? We have our mother tongue, we have our, then we learn when we go to school we learn English language, okay. Using that English language we learn different other subjects, right? We are able to memorize, we are able to understand, right? So different types of languages are there, okay. But computer is a machine, okay. Computer is a machine that, and then in order to communicate with the computer, okay, so a different language has been created for the computer, okay. If you simply type, or if you simply say to the computer, okay, it will not understand, okay. So when you're pressing 1 plus 1, okay, it will actually not understand, okay. It has to be translated into a different language for the computer to understand, okay. And that is called as machine language, okay. Since computer is a machine, okay, so we convert it into machine language, which is called as binary language, okay. It's in the following pages, okay. So computer understands only 0 and 1, okay. Outcome that is in the following page, okay. So keep that in mind, that okay, whatever data or instructions that you're pressing, okay, if you're pressing suppose like A from the keyboard, okay, computer will not understand A, okay. First what it will do is that it has that A has to be converted into machine language. After that only, okay, the computer understands, okay. Okay, third point, it supplies the converted instruction and data to the computer system for further processing, okay. So that is accepted by the RAM memory, and then what it does is that that data, okay, is transported back, that is, it is converted, okay, and then it is transported back to the proper channel for further processing, okay. So if it has to be, suppose like 1 plus 1, that is regarding addition, okay, so that will be sent to the arithmetic section like that, okay, so for further processing. Now similar to input devices, output devices are also interfaces between user and the computer. These devices takes machine coded output results from the processor and converts them into a form that can be used by human beings, okay. So processor does all the work, okay. So the input data that has been entered, okay, gets processed, and then what, that process information, if it is stuck inside the computer only, it's of no use, right? So it has to be uh, delivered. So how does after processing, how does it get delivered? And that is done by the output device, okay. So that means for a computer, okay, if you are entering the data and it is being processed, okay, and if you don't have any output devices created, okay, then it it's useless, right? So a third setup must be there, a third device must be there, that is your output device, through which whatever instruction has been processed should be displayed. So then you have a complete set, okay. So these three things must go hand in hand, your input, CPU, and output, okay. So this is what the output unit does. It sends output, okay. In short, the following functions are performed by an output unit. It accepts the results produced by the computer, which are in coded form and hence cannot be easily understood by us, okay. So what happens is that the data that is being processed is processed by the computer in machine language, right? And then what happens is that that result which is processed, okay, in machine code, okay, then we cannot understand, right? Now if suppose you're typing like I said, okay, the simplest example, 1 plus 1, okay, 1 plus 1, and then the CPU process that and converts it back into machine language, okay, and in the output device also, is suppose in the monitor also, okay, instead of 1 plus 1 equals to 2, if it comes out in binary language, in machine language, in terms of zeros and ones, okay. Now for programmers they will understand, but for naive users and users, okay, if it comes in terms of ones and zeros, okay, if the whole paragraph comes out in terms of ones and zeros, 0 1 1 1 0 0 like that, how will they understand, right? So what is the purpose of the output device then? Okay, second point, okay, it converts these coded results to human acceptable readable form. Okay, so now the process uh, result, okay, the instruction, okay, which is in machine language, okay, I'll just say in machine language in coded format, okay. Now the output device, the purpose of the output device is, what it will do is that it will convert it into human readable form, okay. So the zeros and ones get converted into one, suppose like two, okay, or alphabets like that, okay. Then it supplies the converted results to the outside world, so it delivers that message to the user, okay, in the form of a printer or in the form of your monitor, okay. So that is what comprise of input units and output units, okay. Now next is CPU. Central processing unit is the heart of any computer system. It consists of primary arithmetic logic unit, control unit, and memory unit. Okay, this is the most important part of the computer, also called the brain of the computer. Okay, so what does the CPU do? Now, what is CPU? Most in the note part is is one of the important parts of the computer, also called the heart of the computer, and directs the operation of the input and output device. So the CPU, central processing unit, okay, is comprised of lots of different uh, components, okay. You have there your ALU, you have there your CU, you have there your memory unit, your memory, okay. So it is called as a brain, or brain, just like we have our brain, right? With this we function. If we want to walk, it activates the nerve cells in our legs, then we walk like that, right? Okay, if I want to move my finger, the brain is responsible for that, okay, like that. So what exactly is the CPU? Okay, now most of the students in the beginning, they have a problem identifying the CPU. When we talk about CPU, the CPU does not mean that uh, in terms of desktop computer, mostly uh, students, they assume that desktop cabinet, that box, that huge rectangular box, to be the CPU. Okay, they think that is the CPU, the whole thing that is inside, they think that it is the CPU, but that is not the CPU. The box is actually just, you may call as like, it acts as a rack, a shelf, to hold the different components, okay. So it holds the motherboard, it holds your RAM, your hard disk, okay, all of those components, different physical devices. Now what is CPU is, your central processing unit is actually what you call as your microprocessor, okay, which also we'll learn in the following chapters, okay. So here I'll just show you. I have a very old motherboard, okay, Pentium 4 1. So I'll just show it to you here, okay. So I hope you can see it clearly. So you, here you have your RAM, okay. So these are different slots where you can attach your hard disk, your floppy drive, okay. This is your, okay. So this, as if you can see here, okay, this is your CPU, okay. This is called as, this green port is called as your motherboard, okay. This is a PCB port, which is called as printed circuit port, okay. So you can see here, okay, the behind backside, and here. So this is your CPU, okay, your microprocessor. So in the earlier times, they had the CPU was attached to the motherboard, so it was non-detachable. Like these days, you have your mobile phone, okay, your smartphone, with non-removable batteries, right? So earlier time, the motherboard had non-detachable micro processors inbuilt in that, okay. Then this P4, okay, I have this one. It's like, actually it is, it can be detached, okay, with this. And this one has, actually, yes, you can see here, okay, this, it has pins. So it has pins. I hope you can see. Okay, so the pins, okay, if you bend or break even one of the pins, then this microprocessor becomes useless. Okay, so this is the brain. Okay, so so these days you have a pinless processor. Okay, you have pinless processor, so as to avoid any damage. Okay, now what does the CPU do? Okay, it carries out instructions and tells the rest of the computer system, okay, what to do. So it acts like, okay, it acts like it tells everything, it does everything. Okay, so this is done by the control unit of the CPU. So it's split up into different parts, right? Okay, so performs arithmetic calculations, data manipulations, comparisons, sorting, combining. Okay, so now the inside the CPU, okay, in here, okay, you have your memory, you have your ALU, you have your control unit. Okay, when we talk about memory, I don't mean like memory like your RAM or your hard disk. Okay, it's a different memory. Okay, temporary storage memory. Okay, but very high speed memory. Okay, so in the first part, okay, any kinds of instructions or any kind, when the moment you're pressing from the keyboard, okay, the CPU sends the signal to fetch the data that is being typed from the keyboard. Okay, so the CPU is responsible for that, and that part is what is called as your control unit. Okay, your CU, your control unit. So the moment you press A, okay, the control unit actually sends the signal, okay, to fetch that data. Okay, it sends the signal to the RAM memory. Okay, and then one when you are typing it, okay, the RAM memory will fetch that instruction and then send that to a different memory area that is called as registers. Okay, different types of registers which are very high speed memory units. Okay, so it it holds the it holds the data, okay, temporarily, and stores the data temporarily, so that while the RAM is accessing, uh, receiving the data again, okay, it will keep on processing the previous ones used data and fetch the data like that. Okay, so that is the memory part of the CPU. Okay, and the control unit, okay, in real life term you can call it like your traffic police. Okay, if there's no traffic police, there will be chaos from all sections of the roadways, right? So the traffic police, what it does is that it ensures that there is no traffic congestion, okay, and then it gives proper direction. So the control unit also works the same way. Okay, now, so what kind of work does it do? That comes to the ALU, arithmetic and logic unit. Okay, so the ALU is capable to perform addition, subtraction, multiplication, division, as well as comparison, okay, sorting, combining, etc. So arithmetic logic unit. So what happens is that when you press 1 plus 1, okay, the control unit activates the arithmetic unit, the arithmetic section. So there, anything that has to do with means like equations, mathematical solving, okay, it is done in that section. So it will fetch the instruction and then send it to the arithmetic section unit. Okay, and then what if, but if the computer is meant only to do such or like arithmetic problems, okay, then you have a huge monitor, you have a huge cabinet, okay, and it can do only addition, subtraction, and all these things, right? Then you can say that you have a huge calculator. The small calculator and your huge monitor, it will work same, right? But you have your normal calculator, the small handset calculator, which can do only like uh, maths problem, right? Calculation, right? So division, multiplication, all those things, but it cannot do other things. It cannot say like uh, if you ask some questions, it cannot reply back, right? So that part is your logic unit. Okay, arithmetic logic unit. So the logic unit, what it does is that it is the reasoning part, okay, the factual part, the reasoning part, the comparison part, the sorting, okay. So suppose like a greater than, less than, okay, equal to, is it true or false, okay. So all of those things is done by the logic unit. So that completes the whole components of the CPU. So the arithmetic part, the logic part, so the logic part is equally very much important, okay. Without that, the computer becomes very much useless, okay. So uh, keep that in mind, okay. So all of these things, the processing, so when you have some reasoning to do, comparison to do, the logical unit section gets activated, okay. The control unit sends the signal. Clear? So I hope you have understood what this about the CPU, okay. Now coming back before that, okay, the memory, okay, the memory, the memory or storage section of the computer consists of the devices used to store information that will be used during the computation. Memory devices are constructed so that it is possible for the control unit to obtain any information in the memory. Common storage devices are integrated circuit, that is your IC memories, magnetic tape, and magnetic disk. Okay, so memory is divided in two categories: primary memory, that is, and secondary memory. Okay, your primary memory is your RAM, ROM, like that. Your secondary memory is your hard disk, okay, CD, DVD, Blu-ray, all this, like that, okay. So but here this memory is the registers memory, okay. That is something like accumulator, okay, like process registers, okay. So coming back next to the next topic, that is the memory units, okay. So if you see the textbook, okay, you have the following are the computer memory storage units which stores or holds data, okay. So now we are talking about the storage unit, okay. How the because if that is one of the main advantage or characteristics of the computer, okay. It is able to store huge amount of data, okay. So that is actually one of the greatest advantage of a computer. That's why you're able to store years and years of data in a computer, right? Okay, and whenever you want to retrieve it, you just turn on the computer and then you have a look at it. So without this storage, you just imagine that you are everyone is using internet, right? In internet, whatever data that you're searching for, okay, how you are able to get all those data? You log into you're searching Google, searching something, you're able to get huge page of information. You log into Facebook, okay, 10 years back what photos you have uploaded, it is still there. So how come that Facebook is able to store your data and you're able to retrieve it, okay. So that means it must be stored somewhere.